Hola, gracias. Buenas tardes, Buenos Aires. ¿Cómo estamos?
¿No me dijiste en inglés?
Sí.
Ah,
El otro
Sí,
va a hablar en
yo
inglés.
tengo
ok.
esto, entonces.
A nosotros.
Vamos a mostrar al Valkey por acá. Mi nombre es Roberto Luna. Como les decía, esta charla va a ser en inglés. So, I'm a senior developer advocate. We're here to tell you about Valkey, how you can. I have my colleague Nigel here. He's going to take it off.
Hello. Hello? Yeah? Okay. Cool. Cool. How are y'all doing? Good? How many people have heard of Valkey before? Okay. How many people are using Valkey right now? Okay, we need to get those numbers up. Hopefully, hopefully by the end of this talk, we can motivate you all to check out Valkey and see what it's about. So in short, Valkey is an open source, high performance, in-memory, key value data store. That was a lot of hyphenated words. But in effect, it's a database that runs in memory and the data types, the data architecture is in key value. The important things to know about the project are that it started as a hard fork of the Redis project. When last year Redis decided to change the license to no longer be open source, maintainers and contributors to the project decided at that point that they would fork it and create the Valkey project. So Valkey is fully compatible with Redis 7.2.4, which is where the fork happened. You don't have to worry about anyone doing a license pull, a rug pull license change on you again, because Valkey is now under the Linux Foundation with a BSD3 license that is going nowhere. It's also built by the open source community. There's no one company that's in charge of it. There's no one person making all the decisions. It goes where you want it to go. So you can help us out by choosing the direction of the Valkey project. This graphic on the screen shows a lot of the people who are contributing and participating in the project. Like I said, we have a lot of people who are part of the technical steering committee, so there's no one person or company that's in charge of it. On the steering committee, we have Tencent, Huawei, Amazon, Google, Alibaba, and Ericsson. Most of their logos are represented here on the screen. Because it's a hard fork of Redis 7.2, moving to Valkey is trivial if you're using open source Redis. Effectively, you can think of it as a rebrand because the code is the same. So you can just change your containers, Roberto's going to get into more specifics about how to do the migration. I don't want to get too far ahead of him, but a lot of the things are identical in Valkey and Redis if you're using Redis open source. A little bit about where Valkey came from. It's been around for about a year and a few months. After the fork, Valkey released the 8.0 release. And the 8.0 release focused a lot on quality of life improvements and performance updates. We really wanted to get to 1 million requests per second that Valkey could handle, which now we're doing on a Raspberry Pi in the booth. So if you come to our booth, you'll see our demo where we're getting consistently values that are close to 1 million requests per second. The dual channel replication to help with the connection and enhance slot migration reliability. And then with the Valkey 8.1 release, we focused even more on performance. We had one person who we were doing a benchmark with, and we'll show some graphs later, where they had a reduction in memory footprint of 20% just by moving to Valkey. Valkey is written a lot more efficiently from Redis to Valkey. Just by switching to Valkey, making that upgrade, they were able to save 20% of their memory footprint. We also introduced modules with the Valkey 8.1 release. We have a vector similarity module, a Bloom filter module, a JSON module, and an LDAP module. A little bit more about that later. And then some more observability hacks for new command log and metrics. And then with what's coming in Valkey 9 is set to be released very soon. Multiple databases in cluster mode, atomic slot migration, and expiration of hashful items, which Roberto's going to be talking about shortly. I'll hand it over to him to talk about some migration stuff now.
Thank you, Nigel. Well, let's see how you can take your existing Redis open source databases and bring them over to Valkey. First, let's say you're running an application, whatever that may be, and you're connecting to Redis. Like we said, it's a drop-in replacement if you're running anything on Redis 7.2 and before. So that means that you can just simply change your DNS, and that connection goes down to Valkey, and that's it. That's all you have to do. Fairly straightforward, right? Most of the use cases are going to be like this, where you use Valkey as a cache or as a essential store where you don't need to care about the data. That means you can take over and then have Valkey handle everything. A little bit more complex, and where you're doing a high availability upgrade, where you have a Redis cluster, and then you can make Valkey a replica of that existing cluster because they're compatible. Redis won't know that it's talking to a different server or a different engine. So that means that you can make those replicas, and then suddenly you can just start getting all the data coming in. This is when you have an application that it's actually more in the terms of like a shopping cart or something like that, right? If you have a streaming or gaming application, in that case, you may also want to just upgrade and move to Valkey. If you do have the ability to take a little bit of downtime, you can simply stop the writes, right? You can continue having Redis to be the source of truth for your application and continue reading from it, but then you will be able to take a backup and restore it, the RDB file, onto Valkey. You set up the new cluster, and then do the change of the DNS, that's it, you're golden. And you didn't have to take more than a few minutes of downtime while the cluster is being created.
There's one other thing about migrating to Valkey that we didn't talk about. Valkey is available with a lot of cloud providers as managed services, and a lot of them have tooling as well that will help you get from Redis to Valkey with zero downtime. So back to the Valkey 8.0 release, I talked about the memory efficiency, and here's some more specifics on the chart on the screen. So Valkey 7.2, which again is the hard fork of Redis, we're seeing how the memory usage is about 700 megabytes, give or take. And then with one upgrade in Valkey, we have the per slot dictionary, which yielded a 13.7% memory reduction. So we're down to about 600 megabytes. And then with adding the key embeddings as well, which is another part of why memory is more efficient, we got down to 550 megabytes. So 20% memory reduction. This is a real world use case of someone who's just switched from Redis to Valkey and done nothing else. The multi-threaded performance. One of the things that was added into Valkey that happened after the fork is multi-threaded I/O. So essentially, we're offloading a lot of the processes that need to happen for communication away from the main thread to allow the main thread to do what it needs to do, and be able to have a much higher throughput of commands that are happening, which is how we're able to get to that 1 million requests per second. Roberto, did you want to talk about the specifics on that one?
Yep. So essentially, the core of what Valkey is remains. It's very simple, right? The whole point is that there's a single main thread that does a event loop. So all the commands that are touching memory, reading and writing to it, are going through it. And that's by design. It makes it simple. It makes it atomic. But like Nigel said, we can take advantage of other cores, right? Let's say you're paying for a 4, 8, 16, or 64 core, whatever it is, machine, just for the sake of memory. Well, now you can take advantage of the extra cores as well, because a lot of the time it's spent on TCP connection establishment as well as the commands. So it processes these I/O threads, will process the command, and then we'll hand it over to the main thread. They get the responses, and then they assemble the response back and send it to the corresponding client.
So what is the result of having these I/O threads and offloading of the main thread? What we can see on the top chart is a throughput comparison. On the left, the purple, we have Valkey. On the right, we have Valkey 8, and on the right, we have Valkey 7.2, which again is the hard fork. Bigger is better, so three times the throughput is what we're handling by using the I/O threads in requests per second. And then on the bottom chart, we have a latency comparison, and in this one, smaller is better. So dealing with having the multi-threaded I/O allows us to get much lower latency as well. And in Valkey 8.1, we have a new hash table. So we're showing the per item overhead with 7.2, with 8.0, and with 8.1, it's gotten gradually better. And then some other features of Valkey 8.1. I don't know if there's any ones you want to point out specifically.
Very important, TLS negotiations, right? So we talked about those enhanced I/O threads. So what they do, a lot of time when you creating a new connection, it's spent on that, especially with TLS. Like the whole point of Valkey is that you get microsecond responses, right? Sub-millisecond. But the very first connection that is established, it takes about 100 milliseconds. Imagine, like if you keep dropping your connections, that's going to cause a problem. And you have to do that on both ends. On the clients to use connection pools, but also on the server, we're offloading. The main thread is no longer establishing and making that handshake of the TLS connections. The latency the improvement as well, as you can see, is 90%, right? Up to 90% on P100. That means every single request is guaranteed, or not guaranteed, but it's expected to be sub-millisecond.
So the other thing that we talked about were the modules, and if you don't want to deal with modules individually, we have a release called Valkey Bundle, which puts together Valkey, the Valkey binary, as well as the other modules. And I spoke about the modules earlier, but I wanted to go into a little bit of detail about them. So we have a JSON module that allows you to use JSON as a native data type with Valkey. We have a Bloom filter module, which is a probabilistic way of telling whether something is perhaps in a set or definitely not in a set. We have a vector search module, which allows you to do real-time vector similarity search. And we have an LDAP authentication module, which allows you to take the permissions that you already are using at your enterprise and apply them to Valkey.
I'll jump to Valkey 9. What's coming? This is first time we're talking about it in the public, so really excited about it. First of all, the way that Valkey works is there's a key and there's a value, right? So there's a hash that will expire at a certain point in time. So after the time or the TTL has elapsed, that key is going to be gone, right? But the problem with this is that if you do have a dictionary that you want to set a specific item to be expired at a different rate, you can't. Then you have to extract that out, right? Let's say you do have a attic company, gaming company, or something like that, where you want to keep track of the fields, in this case, a promo code and the value, then you can now expire that item separately. So there's a meta TTL at the key level, and if you want to, you can specify on specific fields when they will expire. Good? Excited about this. I'm super excited. The next is multiple databases or using Valkey as a namespace. The whole point is that you have the ability right now to do this in a single node or the standalone, right? You can still have multiple nodes, but the abilities that you have to extract, or you can extract multiple databases for different use cases. For example, you want to have a database for caching, you want to have a database for sessions, you want to have a database for your counters or sorted sets, etc. The point here is that you can only do this with standalone, where there's a single shard, right? Or all the database goes into the same node. So how it works? Okay, next. This is going to show you how the data is spread in multiple shards. What that means is that there's a logical partition onto which node is responsible for a subset of the data. So as you can see, these are called cluster slots, where each node is responsible for a subset. So in this case, 0 to 5,460, and total 16,384. The way that it works is the clients know where my data is going to go to. So from the client side, there's no overhead, there's no proxy. So whenever you're trying to save a key, like your user, there's a CRC16 hash that is going to yield a number, and that's going to say, okay, you go to cluster slot 12,893, so that's going to go to shard number 3, right? So this is great. It works for spreading out the data, but the problem is it does not have multiple databases. There's a single database. So what happens when you do have to do this? Then you have to create multiple clusters, one for caching, one for sessions, and so on. The solution is to add or extend the database support to cluster mode now. All right? So, is there a question? No, this is at the cluster level. So the question is if it's on the record. No, so the idea is that you select when you connect to the database or to the cluster, which database you want to talk to. So there is the ability to have up to 16 different databases. It's like if you're using a relational, right? There's a database level, and there is this schema, and then the tables. So this is the same concept. The same cluster can now give you up to 16 different databases. This is super exciting for those downtime or no downtime migrations, or whenever you are scaling out or scaling in your cluster. That means that's kind of the great thing about NoSQL databases, that you have the ability to add a new node without affecting the performance of the rest of the nodes or the cluster in total. So the way that it works is that you have to move the keys to the destination node one by one, right? So this is great, but what happens when you want to read multiple keys? Now they have to be redirected to the new node that is responsive over those keys. So whenever you're doing a mid-slot migration, that means it's in the process of migrating the data. You have a source node, you want to try to get that key, and then that key, there is an owner, but they say, oh no, oops, that key is already moved. But who has it? Okay, go and get it from this node. This works fine for single keys, right? But the problem is when you want to do multiple gets. When you say, okay, I want to get key 1 and 2 and so on, it says, oh, I'm sorry, no, I already migrated key 1, right? So this is really important because this is a problem that has existed in Valkey since Redis came with the cluster mode back in 2013. So that means that we've now fixed this problem that has existed forever. So every time that you wanted to do a scale out and then you had clients trying to read multiple keys at once, you were getting stuck, right? You were getting nowhere. But now we have solved this problem. And also, this helps to try to reduce the overhead of moving a large key. For collections, let's say you have a gaming system, and then you have all the players with the scores or whatever that might be. Then let's say you have 1 billion items and a 5 gigabit or gigabyte key. This is going to do it sequentially using the AOF or a penalty file, or a similar approach. Right? And well, this is the AOF format that I was talking about. Okay.
So that was what's coming in Valkey 9. We also want to make sure that you are able to get involved in the project if that's something that you're interested in. All of the information about the project is on our website, valkey.io. I highly encourage you to go there to check it out. We've got docs. We also have on there Try Valkey, which runs in the browser. You don't have to download anything. You can try Valkey straight from the browser on the valkey.io website. If you're pulling containers, Valkey/Valkey is the container that you want for using Valkey in that way. And then we have our GitHub organization under Valkey.io or Valkey-io on GitHub.
All right. So who here, can you raise your hand if you will benefit from lowering the latency in your applications or cutting cost or adding more performance to your applications? Any hands? Everyone, right? Like we all can benefit. Like I'm sure if you go tomorrow and you tell your boss, like, hey, I found a way to go and reduce the number of servers by 30%, I'm sure you'll get like at least a high five. Yeah, the memory footprint alone, exactly. You can reduce it by 20%. That there's a caveat with that, right? So we showed that those are keys of 16 bytes, values of 16 bytes as well, right? So it doesn't work for every use case, but it's expected because that's kind of the average that we observe. We're looking forward to have you. Please come to the links, join the community. There's a link for that.
Yeah, also on Valkey.io, if you go back, on Valkey.io, or no, yeah, you have it, the Valkey community QR code. We have links to like our Slack workspace where we are. We have links to our LinkedIn page where a lot of updates happen, the Twitter and X pages where Valkey has a presence. So definitely scan this QR code and come and visit us at the booth. Thank you so much for your attention. Do we have any questions?
Thank you guys for your. Yeah.
Do we have a mic?
More people.
Yeah, we'll have mics there with the public. So, any questions? ¿Alguna pregunta? Sí, allá al fondo, on the back.
Hello. Can you share some insights about how you reach that 20% improvement in memory? High level.
How did it work?
How you reach it?
How did we reach it?
Yeah.
Yeah, so there's a
How
new
would it
redesign of
work?
the table. So if you ever seen or know how a hash works, essentially a hash table, that means there's the memory, like it's like there's slots, and then you have to define like when there's a clash. So if you, let's say you have key A, and that key A is going to go to a slot 0. And then the next key B is going to go to slot 300, right? So the key C is going to go to slot 0 again for whatever reason. So that means that then you have to start making it's a linked list, and then you have to do a linked list the other way, right? So in order to avoid more and more clashes, like we have to do two levels of slots. So these two levels of lists, or double linked lists, or hashes in general. So the way that we've done it is by flattening it out, right? So we flatten out the in a single space. So all the lookups are all one directly to the memory space where they are. So that's the big improvement that allows us to do that. That's why I said it only works for small key values.
Thank you. Any other question? If not, we have questions from the people watching online. So, how do you migrate data from a Redis instance to Valkey without downtime?
All right, so there were two options that we showed. One is to make your existing, or create a new Valkey and make it a replica of your existing Redis cluster, right? So that's gonna, Redis is not gonna know. It's gonna think, oh, I have another replica of this shard, so that's it, it works. And then you have to tear it down, right? Then you have to do a failover, convert the Valkey node into the primary, and then make the Redis with replica, and then you can create more replicas for Valkey. That's one. The other one is bring in your data, right? Like you take the RDB file, you do a bg save command, saves the data onto an RDB, and then exactly. And there's an online, they making it a replica. The offline is taking a snapshot, bringing it over, and the final, there's third-party tooling as well that you can just read and write if you have heterogeneous clusters.
Great.
And the other question, what are the best practice for testing data integrating after moving to Valkey?
It's the same as you will with Redis. You don't have to do anything.
Okay. So, is there other questions here? Any questions on the audience? No one wants to raise their hand?
Don't be
You,
shy,
you
don't
can
be
do in
shy.
Spanish, we will translate the question. Yeah?
There's one there.
There's one there, yeah.
¿Qué tal? Mucho gusto. ¿Cómo ven esta tecnología de aquí a 5 años?
How do you see this technology from here to on 5 years from now?
5 years from now. Well, if I could predict the future,
Futurology.
I don't know that I would be here. What I've seen about where the project is going is encouraging to me. We have done a lot to raise awareness about the project, to get people to understand the importance of Valkey, why it exists as a project in the first place. And we've been traveling to conferences around the world trying to get the word out about Valkey. And now when we're showing up to conferences more and more, when I ask that question, how many people have heard of Valkey, I see more hands. And to me, that's an encouraging sign to show that the community will grow. What I'm hoping to see in the next 5 years is continued improvement of features that people are looking for that they haven't been able to communicate or have fallen on deaf ears because you're talking to a single company that has their own priorities and roadmaps and everything like that. This is an open source project where we're driven by the community. We need the community feedback and input. And so for me, what I see in the next 5 years is the project continuing to grow, the community continuing to grow, and for Valkey to become what people wish a key value store could be. That's my vision for the project.
There's a lot of work that is happening behind the scenes to try to squeeze more juice out of the boxes, right? So we talked about how we did that 3x improvement to go from 360,000 to over 1 million. If we can try to work on that, we are going to get further. Same, probably I would like to see it as ubiquitous, right? So, okay, good?
Yeah, okay.
Okay, so the next thing will be to everybody, like Nigel said, like in 5 years, I will expect half of the hands to be up, right? Like everybody knows about it, that's the go-to solution for caching sessions, including now vectors. If you have a use case that you need real time, this should be your database.
Great. There's another question here in the front. Hello. We need audio. Necesitamos audio en el micrófono del público.
Well, we can repeat the question. We
Yeah,
can hear you. Go
you
ahead.
can, sí, decir la voz.
My question is, you said that the memory improvement came from letting out the data structure, but there was no collision letting it out. How do you avoid the collision?
How do we avoid the collisions? Yeah, it's a different mechanism.
Can you repeat the question?
Yeah, the question is, how did we make that 20% improvement on the redefinition of the underlying hash table for the main data map or the dictionary? It's like we changed the algorithm, right? So there's folks who are experts on this that are working on it. Actually, I can say it. Yeah, it's coming from Ericsson. So if we think about it, like they used to do cell phones and things like that, right? But they still back up a large part of the telecommunications. So they do need these ultra fast and to have as few servers as possible.
Right. There's another question right next to the guy who. Hay una
I'm curious about what's the coolest project you have seen used.
So, he says
Yeah,
that
the question is who's
the coolest
using the Valkey?
project.
The coolest project. That's a great question.
This is a hard question.
It's a very hard question because I think everything's cool.
Everything.
Like I'm enthused by a lot. I'm very easily entertained. So the most unconventional one, I saw that there was like, not necessarily unconventional, but it was exciting to me because it was a way that I hadn't considered it being used. There was a website that had a lot of users that were streaming like video, like a Twitch kind of thing. And in order to tell whether users were online or not, they had like an implementation where they had every user and then were checking against what was online to be able to display their page to render like how many people were online and which people were online. And that was one that I hadn't considered before. And then recently we had a hackathon at PyCon Australia. We stuck around for the development sprints, and someone built a system to be able to track the trains that move around Australia. And that was really interesting to me too, to be able to predict, how many people are going to be on the train, and using real-time information, they were able to like get things done really quickly by using Valkey. And then a third one that I'll give is one person saying that using Valkey helped clean up their sloppy practices with asynchronous coding, because they needed to make sure that the data that they were putting into Valkey was the right data and at the right time. And so that was another cool, like, it wasn't necessarily a project that I've seen, but it was a way that using Valkey has changed the programming paradigm to enforce good habits.
Great. ¿Tenemos alguna otra última pregunta?
I have two more. Yeah,
Sí.
we have 1 minute. So
Yeah.
there's two more use cases. Who likes gaming? We all like it, right?
Yeah.
Think about any game that you play that is real time. They're probably using Valkey behind the scenes. I've seen it firsthand. Streaming as well. Pretty much every other major platform streaming service out there is using it. Yep, so the idea is scale, right? I've seen it at global scale, and that's really, really exciting.
Great. Bueno, vamos a despedir con un fortísimo
Un
aplauso a nuestros
aplauso
speakers.
a Roberto.
Thank you very much, guys.
Vengan al booth.
Thank you.
Thank you. Great talk.